Buongiorno a tutti and welcome to the Danisi Engineering headquarters. Danisi Engineering is a company that was born 25 years ago with specific skills on vehicle dynamics and chassis engineering. Through these 25 years we were adding a lot of other competencies, methodologies and tools, and nowadays we are a full service supplier that is giving support to OEMs and Tier 1 in developing new products and mainly new vehicles. We put a specific focus on integration, so we were developing a lot of innovative methodologies in order to better integrate the complex system that is a modern vehicle. Here in this facility we have some of the most advanced tools and we will go through these tools. We will present you our methodologies, and to do so I will leave you with Maurizio, that I will join very soon, and we start our tour.
Hi everybody and welcome in Danisi Engineering. In this period, the automotive sector is facing a sort of revolution if we consider the electrification path, the autonomous driving development, and new frontiers in connectivity. The big challenge is to introduce in the market as quick as possible new features and innovative technologies, but keeping in mind the business sustainability. Before to start with the production of a new product, OEMs and Tier 1 have to face a very long validation and testing process, using a lot of prototypes and pre-series cars, tested in very different conditions. Is there a place in which you can have thousands and thousands of prototypes and a plethora of open roads and testing tracks? This place is our Advanced Vehicle Dynamics Center, in which every day we can test different cars with different architectures. We can validate alternative technical solutions. We can judge the performance of different powertrain combinations. So this is our state-of-the-art methodology to support our customers in developing new products.
In the meantime, we have reached our static simulator area. So here we have one of our main tools in the development process, which is, as I said, the static simulator. The main problem to shorten the development time is to start testing and to start the tuning of all the system as early as possible. And one big bottleneck is when the first prototype will be ready. So, with simulation techniques, simulation methodologies, we can start testing actually before that the first prototype will be ready. Here in our static simulator we have actually we can put a car with all the original electric and electronic systems that will be under development, and we can even integrate some important systems, the physical system. So at the end, here we are able to make a kind of testing that is half virtual and half real. So we can integrate parts like the steering rack, and here we have a specific bench for the steering rack that are real components that gets integrated into the virtual prototype. So actually it is a virtual prototype that is bringing around, is making working real parts. In this way we can start the development process very much in advance. And there are a lot of strong points in this kind of approach. First one, as I said, is timing. We can start earlier and be quicker. Second is the repeatability of the testing conditions, because when you are in the real testing, it can rain, it can be colder, it can be hotter. Here we can do as many times as we like exactly the same test in fully controlled conditions. So it's a kind of laboratory conditions. Another very strong point is that we have full safety. We can even try and experiment something that is very dangerous, and if something goes wrong, obviously in this situation everything is safe, is under control. We are using this a lot to make the so-called fault injection testing, that is when we inject some bug in the software to check how the system will respond. And to do this in real world is quite dangerous. Here we can do it in full safety. Another thing that I like to show you is this one. This one is a small test rig that can put hardware in the loop, so on the virtual prototype, the real camera for the ADAS systems, for lane keeping, for the automated driving. The camera is here and not on the car because on the screen of the simulator we have an image that is made to cheat the human eye. Here the camera is in front of a screen where there will be an image that is the same and synchronized with the simulator that will cheat the camera. But now we can go to see our dynamic simulator, which is even more spectacular than this one, where Maurizio is waiting for us. Let's go.
This is the dynamic simulator, the most advanced tool we have here in Danisi Engineering. That is perfect for supporting each step of the technical development of a new product. With this tool you can feel acceleration and deceleration, you can perceive the grip on the road, you can evaluate and judge the powertrain performance of the vehicle. Oh, ciao Giacomo. Ciao Giacomo.
So here we are, and I would like to, I'm interrupting Maurizio, not that polite, but I would like to add a couple of points about simulators in general and dynamic simulator. Simulators in general is something we didn't mention before, is that we have our engineers in the control rooms that can change any parameter more or less in real time. This is very important because you can test two different setups or two different configurations in few seconds, switching from one to the other. Whilst if you are in the real world, if you don't have two prototypes and you have to update the one you have, it can take several hours. The other aspect that is very important is about integration. We were talking a lot about integration. We say that one of the main competencies at Danisi Engineering is integration. With this tool, with the dynamic simulator, we can integrate the driver, so the human, together with the vehicle. In the modern vehicles there is a lot that is done by the electronic controls. The electronic controls needs to keep into consideration the driver. So the driver is acting on the car. The driver is acting as a sensor, feeling what is happening. It is acting as an actuator. So one ring of the control chain is the driver. This tool is a tool that allows us to study the control with the full chain, so with the real driver inside. So this is a way to integrate the reality, again, the driver, a real human, in a virtual methodology. To go deeper into these kind of aspects, into these kind of methodologies, we like to introduce Claudio Annichiarico, who is responsible for Meccanica Fortitude, that is our daughter company that is specifically focused on controls. So thank you for everything from Danisi Engineering. And,
ciao Claudio.
Ciao Claudio. See you.
Hello Giacomo, thank you for your kind introduction and welcome in Meccanica Fortitude. This company was born in 2015 as a spin-off of the University of Florence in close partnership with Danisi Engineering. In this company we mainly focus on development of mechatronic solutions for the automotive industry, and we validate advanced vehicle functions both on road and in a driving simulation environment. This vehicle is a good example of what we do here. It is a fully bi-drive vehicle. Coming from one of our customers, it is a steer-by-wire vehicle, so the steering wheel is not connected with mechanical joints to the front steering wheel. And we are integrating here a brake-by-wire system in which each wheel is actuated by a single actuator. This is to have a good performance on braking. To guarantee a good level of safety, we also installed a fallback unit. So in case of emergency, the fully passive braking system is recovered. And then we have also a feedback unit to provide the correct feeling on the pedal. Since this vehicle is completely drive-by-wire, we can integrate it into a driving simulation environment. This means that a driver can drive this car into a safe environment where he can test all the functionalities of the vehicle and see, for example, if the vehicle keeps being controllable if one of the actuators goes in fault condition. Now I can drop into the car and take a short run into the VDA. I'm starting the simulation. Just a quick run. I'm going to 60 kph. Now starting steering, recovering the trajectory, and going straight and braking. That's it. Thank you for your time, and the connection goes to Modena. Goodbye, thank you.